This is AP Calculus Lesson 2-3. We're talking about the general and power chain rule. So here we are in our unit guide. We are 3/10 of the way after today, and we're doing basic derivatives for a while until we get down here to 2-8. All right, so I'm going to slightly change how we do Cornell notes. I want to be more like the correct form. We'll try it out, and if you don't like it, then we can switch back. But be asking a question over here about what we're doing. This is the answer to the question that you're asking on the left. So if I'm taking the derivative with respect to x of u, there's another way to write that. I can write that like this, du dx. I kind of think of it as multiplying d dx by u over 1, fraction multiplication. So this is the other way of writing it, and there's yet another way of writing it, which is just u prime. And all of this right here is talking about a speed. It's talking about how fast u is changing. So this is how fast u is changing. And I talked before about how calculus is the study of change, and this is where the derivative comes in. We're talking about how fast it's changing now, so it's one of the properties of calculus. All right, the next one is very similar. So Ben, what do we say here? And then arrow, you're going to do the one on the right. D dx, the derivative with respect to x of v is also dv over dx. And how do you say that aside from the symbolic notation? The derivative of, keeps going, with respect to x, perfect. And arrow, that's also known as v prime, perfect. And that's how fast v is changing. We'll just say it for the sake of simplicity. You can also do this. Mathematicians love just doing double quotes, which means look at the line above and copy paste it here with your eyeballs. All right, this one is kind of interesting though, so I'm going to do this one. Actually, the first one you can do yourselves. Anyone want to take a shot at this? You want to try it, Arrow? Dx over dx. So how do I pronounce this before we go to the next one? Exactly, which is, as Ben said, 1. And 1, so whenever you see an x prime, you can think of x prime as 1. Perfect. Other things that I want to say, be thinking of all these kind of as the tangent, be thinking of them as the derivative. There's many ways to think about this. What question did you guys decide to ask on the left-hand side so I can copy it down for my notes as well?
What are some different ways to say derivative of things?
Yeah.
I wish that red line on the side of the paper was like 3/4 of an inch farther to the right.
Yeah, it would be really nice. I bet you could probably buy paper like that or buy notebooks like that.
It would be like 3 times as expensive though.
Probably.
Buy, like, notebooks that are set up like that.
Oh, okay.
But then you just, I guess you have to draw another line.
Yeah, it's always more work. All right, let's talk about the actual topic of today, which is the general chain rule. So let me talk about the general chain rule. So if I take the derivative with respect to x of, let's say, f of g of x. Do you remember the type of function that this is called? It starts with the C. F of g of x. Starts with COM. Close, composite, yeah. Yeah, so this is a composite function. So whenever I'm taking the derivative of a composite function, remember composite function, you evaluate g of x and then you evaluate f of x after that, or f of whatever is on the inside. When you take the derivative of this, you have to be careful. What you're supposed to do, and here's the rule, I'll set this is the same thing as f prime of g of x multiplied by g prime of x. And I'm going to put just giant parentheses around. Oh, I think that we can see that it's g prime of x is its own separate entity. And this is going to be a little bit redundant, but I just want it in our notes, times 1. You might be asking why we're multiplying by 1. I'm going to explain it right below this. All right, so what we've done here is we're taking derivatives. Let's analyze what's going on here. So we have an outer and an inner. Outer, we have an inner, and we have an inner. What are all three of these things? This was our homework last Friday. What's the outer, anyone? Sorry, bad question. What is the outer of the original function that we're taking the derivative of?
F.
Yeah, f of something. All right, Arrow, what's the inner? G of something. And anyone, what's the inner? X. It's the inside of the inside. It's our x. So, and then once we take the derivative, I need to find, and it's a funny name, and again, it's one of those things that if you talk to someone else that's not in this class, they'll look at you really weird. I'm going to call this thing doubter, because it's the derivative of the outer, so doubter. What is our doubter? Just in symbolic notation.
D over dx of f.
Yeah, d dx of f of something, and even more plainly, so you can write it like that, and that's totally fine. I'm going to go as lazy as possible, f prime of something. I like your method better because it talks about what the derivative is with respect to, which really is important once we start taking the derivative with respect to other variables like y. But for a while, we're not going to be doing that, so we can be lazy. All right, what's our dinner? Arrow, you want to try dinner?
Is it G prime of something?
It is g prime of something. And then anyone want to do dinner inner?
1.
There it is, 1. And that matches up to what we see up here. So, and I do want to try to put these pieces together to let you see how they fall into place. So I look first at the doubter. I write down the doubter, f prime of something. The something is the inner. This inner went inside the doubter. Then after I did that, I did the inner inside of the inner. So that's where our x went to. Our x went there. After we did our doubter, then we multiply by dinner. Dinner was g prime of something, g prime of something. The only thing that goes in that g prime is our inner, so x again comes into here. Then I multiply by dinner, which is 1. So that's where everything falls into place. We don't really need to have those arrows in our notes. I just want you to see how that's happening. So let's try an example. And before I do my example, what was the question that we asked so we can have this in our notes? And it has to relate to this thing. Right now we are doing the general. So what's the question that I should be writing?
This is like Jeopardy where you have to guess the question.
Exactly, yeah.
I did this last year. It was terrible disaster, but it might work better this time.
It was a terrible disaster, but it might work better this time.
What question can I ask about the general chain rule? Because that's what we just talked about.
What is the general chain?
Oh man, yep, just like Jeopardy. What is the general chain rule? Oh, great question. Since you asked, it's this thing that I just starred. I guess the 1 should really be a star. It's this thing, and it's a formula that you have to memorize. And there's actually not that much memorization in this class because I will drill it into us so much that it'll just come naturally, hopefully. There are a few formulas that you will have to memorize, like I think we'll eventually learn our first formula that we'll have to full-on memorize by lesson 9 and 10. Those two you're just going to have to memorize because you don't use them that often. So our example. Let's look at, I'm trying to take the derivative with respect to x. I'm trying to take the derivative of, I'm going to keep it still pretty general, not an actual function yet. I'm just going to say 2 times f of 3x. Cool. This is going to turn into something. Let's use our general chain rule on this problem. What is it going to be? This is really hard, applying our brand new rule. So what you're doing in your head, and I'll do it down here, you're finding your outer, you're finding your inner, and then you need to find your doubter, and then you need to find your dinner. Maybe I should do those a little bit farther apart so we have room. Doubter and your dinner. So let's start down here first. What's our outer?
2f.
2f of something, exactly. What's our inner, Arrow?
3x.
3x. Arrow, what's our doubter? And then Ben, you're going to do dinner. Sorry, go for it, Arrow.
2f prime.
2f prime of something, exactly. And then Ben, what's our dinner?
3.
3. Okay. Now let's follow the format up here. So what should I be writing here? Anyone?
2f prime of 3.
2f prime, careful. What goes inside here? This right here wasn't a derivative. It was just plain old inner. So inside here, 3x. Yeah, we didn't take the derivative of the inside yet. You just leave the inside alone. It's kind of like baking a pot roast where you cook the outside and that part until. So now we're going to find the next part where we're going to actually take the derivative of this inside. This inside wasn't cooked, and now it is. The inside, we didn't take the derivative, and now we're going to multiply by the derivative. So we're going to multiply by what?
3.
By 3.
So it's 6f prime of 3x.
Yep, so our final answer, and I'm going to do it on the right, as Ben said, it is 6f prime of 3x. Box our final answer. All right. What question can we ask about this? This example. Maybe the first word will be how. How something right here. What question did you write, Arrow?
It's annoying when you can't just call it example. It should be sensible, but no.
No, you have to ask a question.
Say how example.
How example? If only English was that simple.
What about how do we apply the power chain rule? Whatever. How do we apply the rule? Yeah, that's pretty good.
How do we apply the rule? Perfect. All right. So far, so good. So let's talk about the next thing in our notes, which is the power chain rule. All right, so this one is best done with an example because you're still using the general rule, but now on a different type of house. So example number 2. So let's find the derivative, d dx, the derivative with respect to x of, now it's a full-on example, it's going to be 2 times, let's do 4x plus 1, all of that to the power of 3. All right, so first question, what house are we in? I just said it, but let's see if you can remember. What house is this? What house do you see?
Power.
Powerhouse, yep. So we're in Powerhouse. So first question has been answered. I guess we could write it here in your notes if you want. Your first step should always be saying, what house are we in? We're in Power. And then from there, you're always doing the same thing. Identify the outer. Identify the inner. If it has an inner, identify it. This one doesn't have an inner that I see, so I'm not going to write it down. Once we find the outer, we're going to find the doubter. Once we find the inner, we're going to find the dinner. And then eat it, because it will be delicious, because it's a delicious pot roast. Outer. What is the outer? Anyone? Careful. You're not taking the derivative yet. We're just analyzing the function. We're separating the function into parts here. Outer. 2 of something to the third. Well said. Ben, what's the inner?
4x plus 1.
4x plus 1. Very nice. Ben, you want to do doubter? And then Arrow, you can do dinner.
That should just be 0.
Careful here.
Is it 1?
So we're in Powerhouse here.
It's just something to the third, right?
Powerhouse. So review of Powerhouse, when I had something like 3x to the fourth, Powerhouse, this 4 came down to get multiplied, so it turned into a 12x, and then this 4 went down a power to the power of 3. So that's how Powerhouse worked. Apply Powerhouse rules to our outer to get doubter.
Oh, it's 6 times something squared.
6 times something squared. Perfect. And then dinner. Arrow, you got this?
Is it 5?
Ooh, close. It's not 5. It is 4. Why is it 4?
Because the 1 turns into a 0 and not a 1.
Exactly. This is the derivative of a constant. And this is something that I kind of haven't made a formal note of, but I should be saying this. D dx of 4x plus 1. This is the same thing as distributing this derivative into each of these terms. You can distribute the derivative when you have plus and minus in between. When you have a multiplication sign, you can't really distribute that. It's a separate rule that we will be learning here, the product rule, because products and quotients are really hard in calculus. But you can apply the derivative to each of these. So this is d dx of 4x plus d dx, the derivative with respect to x of 1. And we know that the derivative with respect to 1 is 0. It's the derivative of a constant. And then the derivative of 4x, as you clearly told us, was 4. So that's what's really happening behind the scenes. You're distributing the derivative. Perfect. So we have all the pieces. Now, let's actually fit the pieces together. This now turns into what? Using same rule up here, these pieces come together. We need doubter, put the inner inside of it, multiply by dinner. So let's tell me what to write. And if you want to skip a step, that's fine too.
Is there like a fancy way to say parentheses or something? Or just,
The quantity of?
oh. 6 times the quantity of 4x plus 1 squared.
Squared, okay.
Times 4.
Times 4. There it is. And we can simplify that one step further to say what? This 4 and the 6 can be multiplied.
So it's 24 instead of 6. That's the only difference.
Yep, 24 times the quantity of x plus 1 and parentheses and squared. And got a little bit crunched in here, but it works. Box your final answer. That's what I'm looking for. That's all we have for the notes. Are there questions? We'll get lots of practice in today. All right, that concludes today's notes.